Today's here we will see about the delta star method for solving the resistance circuit in a given network. For example, we have to find here equivalent resistance between point A and B, but here see we did that if we take the ratio of R1 by R2, this is R1 and this is R2, this is R3 and R4, then we get R1 by R2 equal to R by NR equal to 1 by N, and similarly R3 by R4 equal to NR by R equal to N. Hence here R1 by R2 is not equal to R3 by R4, so it is a Wheatstone bridge, but this is not balanced because we are not getting R1 by R2 equals to R3 by R4. So Wheatstone bridge is not balanced. This can be solved by delta star method. Now we will discuss about the delta star method, how delta star method, which type of circuitry is called delta circuitry, and how it is transformed into a star circuitry. For example, here in this case, this represents a delta circuit. From figure it is clear that this is 3 point A, B, C, and point A and B there is a resistance R1, in point B and C there is a resistance R2, and in point C R3. Now this circuit can be transformed into a different circuit as shown in here. That is, if we take a point at this here and connect with this circuit again with we connect this point with a resistance like here, and again with this point a resistance in between like here, and remove these three resistance, then it will transfer like this resistance. Now the value of these three resistance will be given by, for example, if we have connected a resistance here, then this value will be equal to R1 into R2 by sigma R. Similarly, in this resistance will be equal to R2 into R3 by sigma R, and for this in this for this value here, this resistance will be equal to R1 into R3 by sigma R, where sigma R is the total resistance in the delta, that is sigma R equal to R1 plus R2 plus R3. Now this whole arrangement will be changed like this arrangement. So this whole circuit will transform into this circuit with resistance value like this, and this is called transforming delta circuit into a star circuit, because it look like a delta and it looks like a star, and this is the delta star method. Now let's see the application of this delta star method in a problem. Here, for example, here is given we have to find the resistance between A and B. Now we know that this is a Wheatstone bridge, but this is not balanced, so we cannot remove this resistor, but this resistor can be transformed like this, because if we because this point, and if stretch this will be like this, and in this side if we stretch this will be like this. So this can be transformed like this. Now if we see these three, this makes a delta form. Again, if we see this also makes a delta form. So these three resistors represent a delta circuit, and these three resistors also represent a delta circuit. Now we have to convert any one or two which will be convenience for our to solve the problem. Here we are converting this delta circuit into a star circuit like this. So for it, now if we take a resistance in the here, we take a point in between here, and this two resistance will be transformed from a single resistance, and whose value will be R into NR by sigma R. Again, these two will be transformed with a single resistance, and whose value will be R into NR by sigma R, and these through and these two resistance will be transformed by this value R3 R into NR by sigma R. So we have three resistance. Now this circuit has been transformed into a star circuit, this delta circuit, and this is point P and this is point Q. Now we see that this can be solved now easily, because these two are in series. Again, these two are in series, and so we get the equivalent of these two and equivalent of these two, and then these equivalent will be parallel in with each other. So again we apply the formula for a parallel. Now we have assumed this value as R1 in between this resistor is considered as R1. This branch of a star as a R1, this branch of a star as a R2, and this branch of a star as a R3. Okay, so first we have to calculate R1, which comes out to be this value NR by 2 plus N. Similarly, R2 comes out to be R by 2 plus N, and R3 comes out to be NR by 2 plus N. Now the whole circuit will look like this. So this is a point B, this is NR by 2 plus N, that is representing R1, this value R1 NR by 2 plus N, and this is here representing R by 2 plus N and NR by 2 plus N. Now because these are in series and this is our series, so this can be transformed directly added, because in series we add directly to individual value. So this is this plus this will give the equivalent. So here R by 2 plus N plus NR, this is the equivalent resistance of these two, and again this plus this NR by 2 plus N plus R, this is the equivalent of this, and this has been replaced like that. So we are this whole circuit has transformed into this circuit. Now these two are in parallel, so we have to calculate the equivalent circuit of equivalent value of these two, which now this whole circuit will transform into like this. Now this and this equivalent will be in series. Here it is shown, that is this value is NR by 2 plus N, and equivalent of these two are 2R into N plus 1 to the whole square by N plus 2 into N plus 3. We have calculated this value. Next now, so RAB will be, because these are in series, we have to directly add this. Here we see that these are in parallel grouping, so equivalent of these two will be in series with this. Here it is shown NR by 2 plus N, and the equivalent of these two are given by this value. So now we can get RAB simply. Here is the value of RAB. So RAB will be equal to NR by N plus 2 plus 2R into N plus 1 to the whole square by N plus 2 into N plus 3. And taking R by N plus 2 from both term, R by N plus 2, we are left in bracket N plus 2 into N plus 2 the whole square by N plus 3, or R by N plus solving, and this will be N plus 3, or multiplying this with this, the N square plus 3N plus now 2 into N square plus 2N plus 1, value of this whole square, and solving again R by N plus 2, this is N square plus 3N plus 2N square plus 2 to 4N plus 2 into 1 equal to 2 divided by N plus 3, or R by N plus 2, 2N square plus N square 3N square, 3N plus 4N 7N plus 2 by N plus 3, and now this value can be solved like this. For example, 3N square plus 7 plus 2 equal to 3N square plus 6N plus N plus 2, or 3N taking common, the N plus 2 plus N plus 2, and now again N plus 2 is taking common, N plus 2 into 3N plus 1. So we have written here R by 2 into N plus 2 into 3N plus 1 by N plus 3, Now n plus 2 will cancel out, so r into 3n plus 1 by n plus 3 answer. So using the delta star method, we have transformed a non-balanced V test on bridge into we have solved the circuit which is not balanced, circuit of V test on bridge which is not balanced. See again another problem of this. For example, here RAB, we have to find RAB. This is our original circuit A and B, and this is shown here. Here we see that no resistance is in series and parallel. For example, these two are not parallel, and again this is not in with series, so we have to use some another method to solve this. So first, but here we see that these three circuit closed loops are making delta formation. So to solve this, any one of delta should be transform into a star formation. So here I am transforming this part of delta into a star formation. So we have to take one point in between here and then transform this into and transform this all into a star formation. So for here, for example, this will be transformed by this, and this will be r into r by sigma r. So r square by 3r equal to r by 3. And again this point will be transformed by r by 3. Again this point will be transformed by r by 3. This 2 will be transformed by r by 3. Now this point and this point P remains same, P and Q, and new formation has been made here. So this is r by 3, and this is r by 3, this is r by 3, this is r, and this is r. Now again we cannot solve it directly because no one is in series and parallel. No, it can be solved. This is in series but not useful. So but first we convert this delta formation into a star formation. Again, this is the point. You have to clear that this point is R, and so this 2 will be here. The resistance of this point will be R by 3, and in between these will be R by 3, and in between these will be R by 3. Again, this has converted into this delta has been converted into a star formation. Now the final figure will be like this. For example, this is R by 3. This is because this is in these all three are in series, and these two are in series. So taking equivalent of this will be 5 R by 3. That is. देखी छै